Hello, beautiful humans. So today we are going to talk about transforming our logarithmic functions. So just like we have done in the past, all trimester long, we've talked about our most basic versions of our functions, our mother functions, and then what we can do with those AH and K values to transform these functions. And so this is going to be the case for our logarithmic function as well. So basically we're going to say that we have an A value that's going to be out in front of our logarithmic function. And then we have our h value that we, again, subtract from x. And then we have our k value that we add at the end. All of these things do the exact same thing that they have always done. So they're going to, a is going to be able to stretch, compress, or flip our function, reflect rather. And h will shift us left and right, and k is going to shift us up and down. So if we have 3 times log base 4 of x plus 5 minus 8, we know that our most basic exponential function for that would be 4 to the power of x. That base stays the same. So we're going to use that, the inverse of that, to get our most basic logarithmic function. Then we have an a value that we are going to apply. Every output will triple. Next, we're going to apply our h and our k transformations, and then we're going to have our new graph. All right. So what we're going to do is look at this, and we're going to identify our exponential, create a little table for that, create our inverse table of our logarithmic basic function, and then we're going to apply our transformation. So we're just going to take this slow and steady. Okay, so we're going to start just by identifying our exponential. So this is going to be, that base stays the same, so the most basic exponential would be 3 to the power of x. We're going to make our xy chart so we know what this exponential function would look like. So if we take -2, 3 to the power of -2 is the same as 1 over 3 squared, which is 1 over 9. -1 is 1 over 3, so 1/3. Anything to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. So there's my exponential function. And remember, my logarithmic function is the inverse. So I'm just going to swap my x and y values to find what the most basic log base 3 of x, log base 3 of x would be. So now all I'm going to do is just flip my table. So what was my input is now going to be my output. What was my output will now be my input. So 1/9 will give me an output of -2, 1/3, -1, 1, 0, 3, 1, 9, 2. Again, all we're doing is flipping our table here. Now we have to pay attention to our transformation. So one thing I want to think about is we have a vertical asymptote for our most basic logarithmic function at x equals 0. Well, we're going to shift this based on our h value, right? So let's go through and identify what a, h, and k are. So a is going to be -2. So all of our outputs are going to double and reflect. So -2, double and reflect. Okay. We have an h value of +1. So we're actually going to shift right 1 again because we're subtracting that h value. And then our k value is going to be +4. So that's going to shift our whole function up. So the first thing I want to do is redraw my new vertical asymptote. So h has shifted 1 to the right. So my asymptote has shifted 1 to the right. So there is my new vertical asymptote for my transformed logarithmic function. Okay, so what I like to do first is apply my a transformation to a couple of points so that I can see the trend. So I'm just going to pick a couple friendly points, like let's do these 3 right here. So we're just going to take these 3 values. Remember, our a value applies to our output. So I'm going to go ahead and apply my a transformation to each of these outputs. So what I mean by that is that I am going to, wait for it. No. There we go. Okay. I'm going to multiply each of my outputs by -2. By -2. All right. So my new output here is going to be, so this is going to be my point is going to be 1/3 +2 is my transformed point. And then I have 1, 0 still because multiplying by -2 doesn't change 0. And then I also have 3 and 2. All right, so oh, sorry, -2. I was just looking at that thinking I couldn't possibly have the same output for both that 1/3 and that 3, so that didn't work. But I forgot to multiply by negative. So I should actually have -2. 1 times -2 is -2. That's where the problem was there. Okay, so asking yourself if your answers make sense will always help you catch mistakes. So I'd encourage you to do that. All right, so now we need to apply this H transformation. Remember, H is affecting our X values. So for each of these, we are going to add an H value of 1. So we're going to do +1 to this H value, +1 to this H value, or to this X value rather, applying that H transformation of +1. Then of course, we also need to take our K transformation. We're going to add 4, add 4, add 4. Okay, so my new transformed points, let's do those in a new color. Let's do green for my transformed points. So our new point is 1/3 + 1, so 1 1/3, and then 2 + 4 is 6. So my transformed first point that I found is 1 1/3 and up 6. Next point's going to be slightly easier to graph, is going to be 2 and then 4. And then we're also going to have 4 and +2. So let's go ahead and go over to our graph and see what we get when we graph these points. I'm going to start with 2, 4, over 2, up 1, 2, 3, 4, boop. Okay, and then when we go over 4, 1, 2, 3, 4, we only go up 2 now. Again, this is starting to look kind of like exponential decay because of that reflection that's happening here. So remember, we had our logarithm, but then that -2 creates a reflection. So this thing is being reflected in addition to just transformed and moved around. And then of course we have our 1 1/3, so really, really close to that asymptote there, and we're going to be up to 6. Oops, I erased my asymptote. Up to 6 right here. All right, so my new transformed logarithm, ooh, that's messy, but you get the point, is going to look like that. Nice little curve. Again, poor drawing on my part, but again, this has been reflected and shifted. Everything has been shifted to the right one and up 4, which is why it's looking a lot higher than our basic logarithmic function. Again, I would encourage you to check these out in Desmos, make sure they're making sense to you. All right, for the you try, hopefully you are going to try this on your own, see if this makes sense to you. All right, now we have an A value of 1/2. This is going to compress our function. Then we also have an H value of -4, so we're going to shift left 4 this time. Our K value is +1, so we're also going to shift up 1. Notice I started by identifying my base is 2, so my exponential would be 2 to the power of x, and my logarithmic, my most basic logarithmic function, would just be log base 2 of x. So when I evaluate this, -2 would give me 1/4, -1 would give me 1/2, so on and so forth. And then to find my logarithmic, I am doing the inverse. I am flipping all of these outputs here. Now in red, this is step 1 down here. So in red down here, I'm doing step 1, which is applying my compression of 1/2. So I took 0 multiplied by 1/2, still 0, no change there. Then I took 1 and multiplied by 1/2. What was 1 now became an output of only 1/2. Again, every output being compressed by a factor of 1/2 there. Okay, so now I have 2 points and I need to apply my H and K transformations to these 2 points. I have -3 and 1. I need to subtract 4 from all of my H values. And oops, I'm sorry, I read my transformed values, but what we're actually starting with is 0, 1, and 2 and 1/2, right? We're going to subtract 4. That'll get us to -3. We're going to add 1 to our Y values. That'll give us +1. Then we have the point 2 and 1/2. We're going to subtract 4. Again, gets us to -2. We're going to add 1/2. So now we have 1.5. Again, always want to redraw our asymptote, which has shifted to the left 4. Again, your asymptote is going to shift based on your H value because the mother is at x = 0. So as we shift our function left and right, our asymptote shifts exactly the same. So if we shift to the left 4, our asymptote goes from 0 to -4. If we shift to the right 25, our asymptote would go all the way to the right to +25. Hopefully that makes sense to you. So when I go to graph this, I just graphed those points. I added an additional one. I also transformed this point 4, 2 and found out that it would be 2, 0, which is actually my y-intercept there. Make sure we're paying attention to that. Additionally, I would like you guys to pay attention to domain and range on these. So let's go back to this one actually and talk about the domain. Okay, the domain here, remember, logarithmic functions have restricted domains because of that asymptote. We cannot pass that asymptote. So the domain here is going to be greater than, right? So our very minimum value is +1, but we cannot touch that. That's an asymptote. And then we're going to go to infinity. So our domain here would be from 1 to infinity. Our range has no limit. There is no horizontal asymptote on a logarithmic function. So our range is just going to be all real numbers, or you could also say from -infinity to +infinity. That would be fine as well. Okay, down here, again, if we talk about our domain is restricted because we have that vertical asymptote there. That vertical asymptote has shifted to -4. So our domain goes from -4, not included because it's an asymptote, all the way to infinity and beyond. And then our range, again, there is no limit. Notice y is going down forever, and then however slowly on this side, it is slowly growing and getting larger on that side. So we go from -infinity to infinity. Remember, infinity is a concept. It is not a specific number location, so we cannot include it in our value. All right, last but not least example. We have a -1/3 a value. We have no h transformation here, and we're shifting down -6. I took the liberty of creating my exponential chart and my logarithmic chart just to make our lives slightly easier here. Then remember, next thing we want to do is apply our a transformation to at least 3 points. I'm just going to pick my whole number points down here. So I'm going to apply my a transformation simply by multiplying all of my outputs by -1/3. So multiply by -1/3, multiply by -1/3, multiply by -1/3. That will transform all of my outputs by my new a value there. So my new point is I'm going to have the point 1, 0. Again, when I multiply, no change there. And then I'm going to have 5, 5, -1/3, right? 1 times -1/3 is -1/3. And then my last transformed point would be 25 and then -2/3. Okay, so now I need to apply my h and k transformations. There is no h transformation. Let's just identify this is a, right? So it's going to compress and reflect our function. We have no h, so 0, no left, ignore that motion, no left and right shifting because x is just subtracting 0, right? There's nothing there. And then this is our k transformation down 6. So we're going to shift down 6. But if I go to draw my asymptote is not changing. My asymptote is just going to be at x = 0. We have no k transformation, no shift left or right. So now I just need to shift these all down by that 6. We've already applied our a transformation to these red points I've drawn. So now we just need to shift everything down 6. So I am simply going to subtract 6, subtract 6, subtract 6. So now we have the point 1, -6, 5, -6 1/3, 25, -6 2/3. So I'm going to go ahead and graph these points. 1 over 1 down 6. Whoop. And then now I'm going to go over 5 down 6 1/3. Even slightly further right. Whoop. And again, we're going to approach this asymptote, and we're clearly curving down like that. So when you go, whoopers, that's a bad approaching of the asymptote here. You're going to have something that looks like that. Again, I would encourage you to check these out in Desmos, play with them, make sure that they look, that you're understanding what A, H, and K are doing to all of these transformations. And then also I would encourage you to pay attention to both the domain and range on these. So again, the domain is what a typical logarithmic function would be. The domain is going from 0, not included because it's an asymptote, all the way to infinity. The range has no limit, all real numbers, or we could say from -infinity to +infinity. Hopefully that makes sense. Reach out if you have any questions. Have a wonderful rest